the terms of hydrological streams, rainfall is the amount of the precipitations in the form of rain, which is water from clouds that descends onto the surface of Earth, whether it's on land or water. Rainfall develops when air masses travel over warm water bodies or over wetland surfaces. Atmospheric turbulence and convection carries the moisture or water vapor upward into air masses where they from clouds. The clouds eventually release this water vapor, which is dropped as rainfall. The type of rainfall is based on intensity, can be classified as light rain, which between 0 to 2.5 millimeters, and next is moderate rain, which is between 2.6 millimeters to 7.6 millimeters, and the heavy rain, which the diameter is beyond 7.6 diameters. Rainfall depths can be measured by using two types of rain gauge as well. First is non-recording gauge. Non-recording rain gauge only displays the amount of rain that has fallen. This type of rain gauge cannot tell you when the rain is started and when it stopped, what the intensity of the rain was, or how much the intensity of the rain varied over the course of the storm. Next is recording gauge. Recording gauge is an instrument that automatically records the amount of precipitations collected as a function of time. Recording gauge does not require constant observations. The most common types, according to the principle of operation, is first, weighing gauge. This type of precipitation gauge consists of a storage weighing bin to record the mass in which the weight of water collected is measured as functions of time and converted to rainfall depth. And the second one is tipping bucket. A tipping bucket rain gauge is one of the most traditional tools used for weather stations applications. And the last one is float time. This instrument is a recording rain gauge by connecting the float through a linkage to a pen that records on clock-driven chart. The rain passes onto a float chamber containing a light float.
My name is Norizati Nabila binti Roslan, number metric TF210047, and I will present to you regarding the methodology. In this study, the Infobanzi website was used to obtain rainfall data for 4 weeks from April 17 to May 14, 2022. The necessary date is entered into the website and a hydrograph displaying the rainfall statistics is generated. Other than that, Google Earth Pro application is utilized to collect the critical information about these stations, such as topographical profiles and gradient slopes between stations. Based on the precipitation and geographical features of the rain station and water level station, the data will be computed using the mean area rainfall technique, which is an arithmetic mean method, the Thiessen polygon method, and the iso-HYDROLOGY method. This approach works well for calculating average precipitation, and this is the formula or equation that is related to the method respectively. Next, 3 hydrographs are yielded using straight line method. Straight line method is the simplest method where the beginning of direct runoff at point A will be go to the end of direct runoff at point B by a straight line. If the point B is not well defined, a horizontal line will be drawn from point A. Last but not least, the peak flow is calculated using rational method from the equation that is shown below, and the discharge of the river at the maximum water level are calculated using Manning equation based on the cross-section profile of the river using formula given below. Next, I will pass up to my friend. Thank you.
For data presentation, there are 2 sorts of data that must be collected in this study, which is rainfall data and water level data. Those data were taken daily for 4 weeks, starting on 17 April until 14 May 2022. The Department of Irrigation and Drainage provide all rainfall and water level through the public Infobanzi website. An issue happened during the data recording procedure, resulting in no data being captured and distributed by the website for a specific date. It could be due to a website technical fault or a data reading and recording error. Okay, first of all, for rainfall data. To collect rainfall data, several nearby stations in the same state and district were chosen as research location. The chosen stations are usually plugged in by difficulties and flooding in the area. Rainfall data for a single day is usually captured at midnight in order to calculate the overall amount of rainfall data for that day. Bekal Bantai Station, Pintu Air Kelantan Station and Sungai Manggis Station are the three rainfall stations chosen in Kuala Langat, Selangor. The following is the rainfall data that has been recorded for the three stations for 4 weeks. This table shows rainfall data for Bekal Bantai Station. Second station is for Pintu Kelana Air, and last but not least for JPS Sungai Manggis. Next, for water level data. To collect and analyze water level data, one station was chosen as the study location. Typically, water level station and location has been established or put in area close to the river. A station will produce a reading of water level data that fluctuates, either increasing or decreasing. Due to the non-fixed water level data reading, the study has taken the highest data in a day as the water level data for that day. Based on the public info Banjir website, there are 3 levels of water level threshold value, namely like normal, alert, warning and danger level. At the alert level, the water level has risen significantly to above the normal level. Meanwhile, the warning level is their river level start rise to near flooding level. Lastly, danger level, where the river water level has overflowed and caused by major flooding.
And I'm gonna present about the analysis and the result for this project. For this project, there are about a few requirements that we have to analyze, such as for the rainfall data, we have to use the mean annual rainfall to calculate the data for rainfall. After that, we will use the hydrograph to calculate the water level data. And lastly, for the peak flow, we will use the rational method and also the cross-section method to calculate it. Okay, for mean annual rainfall, there are about 3 methods that we have to use. First is the area method, mean method. Through this method, we have to collect the 7 data from each station, and then we will collect the average of the data, and the result that we got is 10.93 millimeters. The second method is Tisian polygon method. By using this method, we have to calculate the area for the study area, and then by we obtain the catchment area, we will multiply it with the precipitation, and the result that we got from this method is about 8.88 millimeters. And now the last method is isolated method. In this method, we need to do the interval line to separate a few areas to search each area. In this method, the result that we got is 8.06 millimeters.
So I will present about stream flow or water level data at station Sungai Langat, DPS Sungai Manggis, Kuala Langat. A hydrograph is a graph showing stage, discharge, velocity or other properties of water flow with respect to time. Based on the water level data from the website Info Banjir, a hydrograph was plotted in table 1. So the table 1 show the data from the website in 4 weeks, started from 17 April 2022 until 13 May 2032. Every change of water level are collected. Alright. this data for week 1 and week 2. Next for week 3 and last for the week 4. Alright, next for the hydrograph for water level. Right, for this figure show the graph of water level. Okay, this figure below show hydrograph with precipitation time was selected at first week, which is at 20 April 2022. Alright, for the unit hydrograph, the selected method for hydrograph separation to process our data into the direct flow is straight line method. Alright, okay, for the straight line method, we just pull the line right for the third point. We just pull to the point A, and we just plot the data into the table to find base flow and direct flow. Right, from this table, how we want to find the direct flow, the base flow, or 1 hour UH ordinate. Right, from the table, how we want to find the direct flow and 1 hour UH ordinate. So this is the example how to find the value. Alright, for the direct flow, we just minus the value of discharge and the value of base flow. So here we got 2,1565 meter square per second. For total direct runoff volume, we just use the total value of direct flow. All the value direct flow we put together and we total all the value. So we have here 9681. We minus by we multiply by 1 and multiply with 3600, and we got 348,51600 meter square. Okay, for the runoff depth, the formula is total direct runoff volume divided by catchment area. So we get 363.04 centimeter. Okay, last but not least, we must find the UH ordinate. For the UH ordinate, we just use the direct flow divided by runoff depth. So we get 7.07 meter cube per second per cm runoff. So after determine of UH ordinate, the UH hydrograph is plotted like this. Okay, this is for unit hydrograph. So the line for the orange color is for the direct flow, and for the blue color is UH ordinate. Alright, so this figure show unit hydrograph of the proposed catchment area. That's all from me, thank you.
Now I'm going to explain about the rational method that we are going to use to search for the peak flow. First, we need to calculate the overland flow time, which we call TO, which TO have its own formula, and the requirement value for the formula that we can see it. We can search it from the runoff coefficient table and also the Horton roughness table. Okay, for the N value, which we got 0.015, we get it from the Horton roughness because the land surface for the study area is paved. And for the L value we got it from the length of the slope. And after that, for the S value, we will calculate it, and we got 0.0427%. And after that, after we put all the information in the formula, the overland flow time that we got is 57.7 minutes. Then we will calculate the peak flow by using the formula C IA divided by 360, which the C value is 0.90 and the I value is 68 millimeter per hour, which we get from the IDF curve. And after that, the catchment area 5,000 hectare, which we get from the catchment area that we change the area from kilometer second to the hectare, and the peak flow that we got is 2,550 meter cube per second. Now I'm going to explain about the last method that we are going to use in this part of analysis result. We are going to use the cross-section method, and this method will be used to calculate the slope for the study area. Okay, first we must calculate the slope area method by using the S formula, and after that we will need to calculate the weighted parameter for every cross-section. For information that we will be using, we will choose the 3 cross-section to calculate the parameter for each slope. And after that, by using the Manning roughness coefficient table, we will choose the value from the type of drain or pipe. And for this area, for this study, we have been choose 0.035 because it is for the short grass cover drain. And lastly, we will calculate the discharge for every cross section. In this table, we will calculate the discharge by using all the data that we get, such as the subsection, slope, Manning roughness, weighted perimeter, cross-sectional area, and also the hydraulic mean radius. All of this will be calculated, and for all the cross-section, we will get the total for all the slope that we have been choosing. That's all. Thank you from
I will present to you regarding the discussion. All rainfall data is collected in real time using the website Infobanje. The data sets were gathered between April 17 and May 14, a period of 4 weeks. Rain patterns differ from station to station due to differences in topographical features. The rainfall intensity can be classified as light, moderate, heavy, or very heavy. And the figure depicts the classification of rainfall intensity as light, which is 1 mm to 10 mm, moderate 11 mm to 30 mm, heavy 31 mm to 60 mm, and very heavy is more than 60 mm. After data collection, it was found that the JPS Sungai Manggis station recorded a light rain reading, which is 2.5 mm. The Pekan Banting station recorded a moderate rain reading of 23.5 mm, and the Pintu Air Kelanang station recorded a heavy rain reading, which is 38.5 mm. That's all from me. I will pass up to my friend. Thank you.
And the last one is conclusion. In conclusion, the mean area rainfall is the precipitation at the area which our selected location to collect the data expressed as an average depth of liquid water over the area. The rainfall data was calculated and recorded because it is important for weather forecasting and facilitate policy decisions regarding the cropping pattern, sowing that constructions of road, and providing drinking water to urban and rural areas. The amounts of data were added together all of the monthly, which use measurement in inches because rainfall is generally measured in inches. The data is divided with the number of the years in your data to arrive at the average monthly rainfall at our location area to get the final values needed. The method that been used as mentioned at methodology and analysis facilities in order to get the accurate amount values based on the rainfall data that collected at our selected location area. That is all from our group. Thank you.